Okay, today's topic is areas of regular polygons. We have two objectives. We're supposed to be able to find the angle measures and to be able to find their areas. What we have over here on the left-hand side of our screen is a regular polygon. It's regular because all of the sides are congruent and all of the sides are congruent. And all of the angles are congruent. So I'm marking all my sides congruent so I know that I'm looking at a regular polygon. And then again, all of my angles are congruent. So congruent, congruent, ooh, what's that? Congruent, all my angles are congruent. So with that information, knowing I'm looking at a regular polygon, then I also have to come up with these two other pieces of vocabulary. I have a radius. Normally we talk about a radius with respect to a circle, but polygons have radii also. The radius in a polygon is the distance from the center to the vertex. And of course, the center is the middle of my shape right here. So here's my center. And it can be located a variety of different ways. We don't need to do that for this lesson, but know that you have to have the center of your figure. It is going to be where all of your radii come from, as well as all of the apothems, which is this green line. The apothem is a perpendicular distance from the center to the side. And so it's right angle here. So this is forming one of those wonderful right triangles that we use for our right triangular trig and other such things. So we're going to be using that information going forward, so don't put it away. Make sure you've got it there handy in your mind. Okay, so the first thing that we're going to do is we're going to do a problem where it says the figure is a regular polygon with a radii and apothem. So we're gonna draw a regular polygon. So, and it doesn't have to be beautiful, it just has to be functional. So my regular polygon is going to look like this. And you just do this to sketch yours in. And then we're going to draw in what are considered all of the radii here. And then I'm going to draw in the apothem as well. And I'm noting that it's a right angle. Okay, so those are my radii and my apothem. Then I know that this right here, this is angle 3. This is angle 1. And this is angle 2, and we're going to find all of those angles. So how do we find angle 1? Well, the measure of angle 1, sorry, I'm having to figure out how to, so the measure of angle 1 is equal to 360 divided by 5. Why 360? Because this technically would be considered a circle. There's 360 degrees as I rotate around the interior of the center. And then I'm going to divide that into the 5 triangles that are here. So that's where that comes from. So the 360 divided by 5 is going to give us 72. So that is 72. The measure of angle 1 is 72 degrees. The measure of angle 2 is equal to 1/2 of interior, the angle measure of it's 1/2 of angle 1. This apothem intersects and bisects this interior angle, right? This angle right here. So this is going to be 1/2 of 72, which is going to give me 36. So then the measure of angle 3, this angle right here. Remember the interior angles of a triangle are 180 degrees. So the measure of angle 3 is going to be the 180 minus the 36 minus the 90, which is going to be 4. So the measure of angle 3 is 54. And remember, these are all degrees. So that's how you'd find the measure of the interior angles of Pentagon. Now let's say we have a hexagon. Let's do a hexagon. So here's my hexagon. I'm going to draw in this really lovely hexagon, right? We're sketching, so it's not beautiful. And I'm doing it on here, so it's even less beautiful. I'm going to draw in all my radii. And then I'm going to draw in my apothem. Okay, I want to find the angle of the interior of this figure, and I'm going to find, again, I'm going to label them. I'm going to find angle 1, I'm going to find angle 2, and I'm going to find angle 3, right? So the measure of angle 1 is, again, this whole thing is going to add up to 360, is going to be, whoops, that's supposed to have a 1 in there, is going to be 360 divided by 6 this time, because there are 6 triangles, which is going to give me 60. Then the measure of angle 2, remember angle 2 bisects this, that angle up there. So that's going to give me that the measure of angle 2 is 30, which makes that the measure of angle 3 is the 180 minus the 30 minus the 90. So that makes my measure in angle 3 equal to 60 degrees. So in this particular case, I have a 30, 60, 90 right, special right triangle. Okay, that's how you find the interior angles of polygons. Now let's say we want to find the area. Well, first of all, let's talk about some of our theorems. We have a theorem that's, or a postulate that says that if two figures are congruent, then their areas are equal. So that's one piece of information. So if I tell you that the figure right here is, its area is 720 square units, and I tell you this one and this one right here are congruent, then I know that both of them have 720 square units as their area. Another theorem is that the area of a regular polygon is half of the product of the apothem and the perimeter. So there's your formula. So to find the area of a polygon, it is actually equal to 1/2 times A times P, where A is the apothem and P is the perimeter. Now, to find the perimeter of any shape, remember it's the sum of the sides. So the sum of the sides, let's look at a problem. So let's say I have a decagon. A decagon, D-E-C-A, is a prefix that means 10. So here's my decagon. Let's draw in my decagon. And again, this is just a sketch because I am doing my best to just get the information on the board, right? So it won't be beautiful or perfect. I know that I need to have information to do this, right? So I need my decagon to have some information. In this case, it gives me that my center, my apothem is 12.3 inches and that the length of the side is 8 inches. So my apothem is 12.3, and the length of my side here is 8 inches. So these are given to me. So if I want to find the area of this shape, then the area is going to be equal to 1/2 the apothem, which is 12.3, times the perimeter. Well, the perimeter, so let's go over here. The perimeter is going to be 8 plus 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 8, or because it's a regular figure, it's going to be 8 times 10 because there are 10 sides. So my perimeter is 80. So this is going to be 80. And then I multiply that out. I'm going to get that my area equals 492. My area is 492 inches squared. So make sure you put your units. Okay, so let's try another shape. Let's say I have an octagon. So let's get an octagon on our paper. So here's my octagon. I'm going to draw it in my octagon. It is 8 sides, right? OCT, like an octopus, 8-sided. And I'm just drawing in my pieces so I have a general shape. Then I'm going to draw in whatever I can draw in my radii. In a octagon, the radii actually go through the center and they find your center point. So it's not beautiful because I did it that way, but let's make it prettier. There's my center. Okay, now I need my apothem drawn in, so I'm going to draw in my apothem. My apothem is going to go from here, just like that. Not beautiful, but done. Okay. And I know that my apothem is 14.5 centimeters. So this is 14.5. And I know that my side length is 12 centimeters. And so if I want to find the area, I just go the area is equal to 1/2 of the apothem, which is the height, right, from the center to the side, 14.5, times the perimeter. And again, the perimeter, this is a octagon, so it's 8 sides, and each side is 12, so this is going to be 8 times 12, which is going to give me 96. So this is 96. And when I multiply that out, I get that my area is equal to 696 centimeters squared. That's what there is to finding the area of a regular polygon. But sometimes we have to use something special to do that. So let's clear some space here. Go back to my Anyway, so now we're going to do a hexagon. Hexagon. So let's draw in our hexagon. So here's my shape. And in this particular problem, they tell us that the length of the side is 3 centimeters, and it wants the area of just one of the triangles. So drawing in my radii and my apothem, because I think I'm going to need them, I'm going to label that this is 3 inches. I'm sorry, this is 3 millimeters. And I need to find the rest of this information. So I actually need to find the size of this triangle here. So it's a 6-sided shape. And I know that this is 3. So half of that, this distance right here, is 1.5. This is a hexagon, which we did earlier, and we found the interior angles for the hexagon were all 60 degrees. So this is 30 degrees right here, right? But if you can't remember how to do that, let's just do it real quick, right? The interior angle is 360 divided by 6, which is going to give me 60. And then this is half of that, so it's divided by 2. That's where the 30 is coming from. Okay, so the 30 degrees comes from there. This is a 90-degree angle here, so this is a 30, 60, 90 triangle. You can get that from subtraction if you need to. Your 180 minus your 30 minus your 90 would give you 60. So there's your angles. So now I know that I have a 30, 60, 90 triangle. This is a 1, 2, root 3, right? And to find the area of a triangle, it is 1/2 the base times the height. In this case, it's going to be 1/2 of 1.5 times the height. And remember, this is 30, 60, 90. So this is 1, 2, root 3. So this is going to be 1.5 times the square root of 3. So for those of you that are going, what is she talking about? Let's just real quick do that, right? In the 30, 60, 90. This is a 1, 2 square root of 3 relationship. So this side is 1 square root of 3 times this side. So this is going to be 1.5 times the square root of 3. And I'm going to multiply all that out. That is going to, it doesn't have to stay in so that's going to be approximately 23.38. So this is approximately 23.38 millimeters squared. So if you have any questions, I'm going to be available for a Zoom meeting. I'll send out the information for that. And you will be able to log in on Tuesday to ask me questions, and I can go over a few more example problems and answer any of your questions related to using Teams, which is what we're going to communicate through. So hope all is well with you. Have a good afternoon.